Welcome back. So in this video, we're going to create a confidence interval for the mean, following up on our confidence interval for the proportion that we did a few minutes ago. So here, um, let's do it for the house prices so we can get an idea of what the range of house prices will be. And just as I did with the fireplaces, I'm going to get some initial information like the mean or average price. There's a neat thing here. If you go to the auto sum and click down arrow, you can do a quick calculation for the average. Very handy. Maybe we'll pop up the decimal. And then the standard deviation isn't quite so easy. I'm going to type that one in. That one's going to be STDEV.S. And I find that this works better if you just type it in. B2 to B40 is our range. And we'll even up that. And then the sample size N. Here we can just use the count function, again, B2 to B40. And that one we should format not as a dollar, but just in general. Now we've got all of our inputs. So I'm going to go to a new tab. Oh, and before I forget, let me save this as version 9. Now we've got basically a file that goes with each Camtasia video in this section. Create a new tab, maybe make it a little bit bigger, font size, make the column A, just like we did before. We're going to list out all the inputs needed. And of course, I need to underline that. First thing we have is our sample mean, which was 208.3, or 208,300. Our sample standard deviation, which was 67.3. Should I take it back? The sample mean was 208. I added a 0.3 unnecessarily. The sample size N was 39. And now we start calculating some things. First, we're going to calculate our calculated t-value in this case, because we're working, again, with sample information, and we don't know the population standard deviation. So there's a neat formula for that. Go to Formulas, Insert Function. It remembered we were using statistical, and there's something called tin.2t, which assumes we're looking for a t-value for a two-sided, or in this case, two-sided confidence interval. We need a probability, which is going to be 1 minus our confidence level, which we forgot to put in. So let's do that. Let's insert one more input. And we'll use a more standard 95% here. Then we'll go back and insert that function, which was near the bottom, t inverse dot 2t. See that it needs a probability and a degrees of freedom. Our probability is going to be 1 minus our level of confidence, 1 minus our level of confidence, or 0.05, and that 0.05 will be spread over two tails. Our degrees of freedom is going to be n our sample size minus 1, so it's kind of the backwards. And that will give us a calculated t-value of 2.02, etc., etc. Now we're going to calculate our calculated standard error. In this case, our standard error is the standard error of the mean. And before I forget, try to be diligent about putting the formulas for any cells that have a calculation right next to them. So our standard error is pretty straightforward. It is our sample standard deviation divided by our sample size raised to the 0.5, which is a short way of saying S over the square root of n. And of course, we'll put that formula in the cell to the right. And we'll get rid of the apostrophe. Hope you've got the hang of that by now. Now here, just another note, I'm leaving lots of decimals, although in the final version, we will clean that up a little bit. Now we're going to calculate the lower limit for the interval. So we start with our point estimate sample mean. We subtract our calculated t-values. Notice again, for 95%, it's going to be pretty darn close to 2. And we multiply that by our standard error. And that gives us our lower limit. I'll copy that formula over. And get that formula back. And we'll calculate the upper limit for the interval. That's going to be equal to the sample mean, this time plus the calculated t times our calculated standard error. Get that formula for you. And so now we can write out the interval. Where we'll start by taking the lower limit, just copying it down here, but this is a good time perhaps to reformat it. And we'll do it in currency with 1 decimal, less than or equal to mu sub x, where x in this case is our price, and mu is our population mean. Of course, let's utilize that format painter function again to make those look the same. So there's our written out interval. Now let's add some managerial conclusion or interpretation of this. I am 95% confident that the true population mean price of the houses, of the homes, is between 186,200 and 229,800. Just notice when I write it out in the interpretation statement, I've written it out in something that you would see in the paper or written down, where I'd write out 186,200, where here and previously we'd worked in numbers in terms of thousands. I hope this is helpful. We'll see you in the next video.